Yeah, we want to look into change of subject of formula. When you have C equals to 2 pi r, actually this is circumference of a circle. As we can see here, C is the subject of the formula in the sense that it is equals to 2 pi r. It is only C that is equals to 2 pi r. That is to say, C is depending on these values. Without these values, you cannot know the value of C. C is dependent on this R. Pi is a constant. 2 is a constant. But in this case, you may be asked to make another variable there as the subject of the formula. For instance, we have two variables, C and R. So when you are asked to make R the subject here, the subject of the formula, that is to say, you should make R to stand alone, R to be equals to the rest. So from C to be that is equals to 2 pi R, how can we make R the subject of the formula? We can see that we have 2 pi to be associated with R, and the association is by multiplication. Then what do? We can divide both sides by 2 pi, because it is 2 pi that is associated with R. So dividing both sides by 2 pi, we have C divided by 2 pi R divided by 2 pi. So this 2 is cancelling this 2 pi for pi. And as you can see, R is standing alone. We can rewrite C divided by 2 pi is equals to R, i.e. R equals to C all over 2 pi. So we have our R to be standing alone now. That is to say, R is now dependent on C. R is dependent on C. So anytime you are asked to find the subject of the formula or to make a particular variable the subject of the formula, then it is very easy. For instance, here we have C to be the subject, C equals to 2 pi R. So our intention is to make R the subject of this formula. Then you should know the first step to take. The first step to take is to remove any other terms or variables associated with what you are making the subject of the formula. For instance, now you have 2 pi r. So what are the terms that are disturbing r? Just 2 pi. And what is the relationship between 2 pi and r? It's just multiplication. Since multiplication is the relationship, the only way you can remove 2 pi is to divide by 2 pi. Now, when you are dividing this side by 2 pi, you must also divide the other side. That was given to you when you were treating solving equation. Whatever is done to the right hand side must be done to the left hand side. Now, the only way we can remove this 2 pi is to divide by 2 pi. So that is why we said divide both sides by 2 pi. So this side too must be divided by 2 pi, so also this side. Then in that case, we have successfully made R the subject of the formula. That is to say, we have successfully made R to stand alone. Now, let's look into another instance. In a situation whereby you have S equals to ut plus half at squared. Now, somebody is asking you here to make A the subject of the formula. That is, make A the subject of the formula. I think you don't need to ask me any question there. That's what do you mean by make A the subject? The question is that make A to stand alone. Unlike this, A is associated with other terms. So we want to make A to stand alone just the way S is standing alone, which means initially S is the subject of the formula, but we are interested in making A the subject of the formula. As we can see here, A is standing somewhere in the right hand side, and A is associated with other terms too. But the first step you need to take here is to remove every other thing from A, so A can stand alone. How do we start removing? Our first agenda is to remove UT. How do we remove UT? How is UT associated with A? UT is associated with A by addition. Then since it is addition, the only way we can eliminate UT is to subtract. We just subtract it. Since it is being added to A, then the only way we can remove it is to what? Is to subtract it. We just say subtract UT from both sides. That is S minus UT equals to UT plus half AT squared minus UT. Now in this case, UT, this is UT, this is minus UT. Then what is UT minus UT? We have 0. UT minus UT is 0. So we have S minus UT to be equals to half AT squared. Half AT squared. We have successfully removed UT from A. Now the next step we need to take is to remove half. We want to remove this 1 over 2. How can I remove 1 over 2? 1 over 2 is associated with A by multiplication. It simply means 1 over 2 times A times T squared. Then how do I remove 1 over 2? Now, do you ever imagine that when I multiply this place by 2, 2 will cancel 2? Yes. I'm going to multiply both sides by 2. That is 2 times S minus UT is also equals to 2 times 1 over 2 AT squared. And you understand the essence of multiplying 2 by 2, so that this 2 will be gone. So 2 cancel 2. What I have left in that side is AT squared. That is, I can use, okay, I have 2S minus UT to be equals to AT squared. Now don't forget what we are making the subject of the formula. We are making A the subject of the formula, but we still have something associated with A. And what is that? T squared. T squared is still attached to A, and we want to make A to stand alone. Then how do we do that? Now the only way we can do that is to divide both sides by T squared. What is the essence of dividing both sides by T squared? You already know. In order to make A to stand alone. And how do we make A to stand alone? Since we know that the relationship between A and T squared is multiplication. And for us to eliminate multiplication, you must divide. For you to eliminate addition, you must subtract. For you to eliminate subtraction, you must add. For you to eliminate division, you must multiply. Now, the association between A and T squared is multiplication. So we need to divide both sides by T squared. Divide both sides by T squared. That is 2S minus UT divided by T squared is equals to AT squared divided by T squared. Now there is no term that T squared can cancel here, but this T squared has cancelled this T squared. A is standing alone here. That is, we have 2 into bracket S minus UT all divided by T squared is now equals to A. So A is successfully standing alone here. A is successfully standing alone here. So we can say A is also the same thing as 2 into bracket S minus UT divided by T squared. Then we have successfully made A to be standing alone. Now let us recap. We have s equals to ut plus half at squared, and we are to make a the subject of the formula. That is to say, we are to make a to stand alone. Now the first step we need to take is to remove this ut from that side, because without you removing this ut, there is no way you can get to where a is. There is no way you can free this a from bondage. So you need to remove this ut. How do we remove ut? How is ut associated with a? It is associated with a by addition. And how do we eliminate addition? I said it earlier, you subtract. That is the way you can remove addition. You what? You subtract. That is why we said subtract ut from both sides. Whatever is done to this side must be done to the other side. If you want to remove ut from this side, you must also remove it from the other side. Otherwise, your equation will not be balanced. That is why we said subtract ut from both sides. So you have this s minus the ut we are talking about to be equals to ut plus half at squared. No, minus the ut we are asked to subtract. So we can now have ut minus ut, which is 0. This ut is gone because we have subtracted ut from the whole. Now we have s minus ut to be equals to half at squared. Half at squared. In that case, it is a that we want to free from bondage. We notice that half is also part of what we need to eliminate. We don't need half. We don't need t squared, but in order for us to remove this 1 divided by 2, that is division. We want to remove division. How do we remove division? We multiply. That is why I want to remove this divided by 2. I'm going to introduce multiply by 2. And if I should multiply by 2 in this side, I must also multiply by 2 in this side. So that is why I said multiply both sides by 2. You say multiply both sides by 2. So you have 2 times s minus ut to be equals to 2 times half at squared. 2 has cancelled 2. We have eliminated that 2. So what we have left in that side is at squared. And don't forget, it is a that we are interested in. Any other one associated with a must be removed. So how do we remove t squared? You ask yourself, what is the relationship between a and t squared? That is multiplication. At squared simply means a times t squared. What did I say? It means a times t squared. So how do I remove multiply by t squared? Then I'm going to introduce divide by t squared. So that's why I said divide both sides by t squared. So in a nutshell, you have this, and you have your a to be equals to 2 into bracket s minus ut all divided by t squared.